Hello guys, welcome back to my channel. As you have already seen, I have already started one Node.js and AI series. So I have already uploaded one video based on cosine similarity. So if you check my previous video, you will see how I have implemented cosine similarity in Node.js. So in this video, I will describe how Tf-Idf concept works in Node.js. So Tf-Idf means turn frequency and inverse document frequency. So I will implement Tf-Idf in Node.js in this video, but this video will be a little bit longer, so that's why I have actually segregated in few parts. So today in this video you will learn the mathematical aspect of Tf-Idf and how I have implemented Tf-Idf, which library I have used for implementing Tf-Idf in Node.js, and that library is natural library. Natural is basically for NLP, so that means natural language processing. This is basically process human language, any form of human language. So natural I am using in this video for implementing Tf-Idf. So in this video you will learn these two. In the next video, which I will upload maybe tomorrow or day after tomorrow, I have made one simple project based on Tf-Idf, that is basically resume matcher. So I will give the job description, and based on the job description it will recommend me the best specified resume. So that I have also implemented, that I will upload tomorrow or day after tomorrow. Please follow this video series, you will learn a lot, probably I guess, and I hope this video you will enjoy. Thank you. So in this video I will explain what is turn frequency and how we can calculate turn frequency of a sentence, and also you can take an example like how Google search works, that huge Google search which we use on a everyday or daily life, how that search works appropriately and absolutely correct. So the model or the mathematical calculation behind it, like they are using some model which support basically large Tf-Idf concept, right, for processing large data set. So like here we have taken one sentence, the cat sat on the mat and the cat is cute. Okay, so now here we will count what is the turn frequency of the term cat, right? So as you see, so for counting the turn frequency of the term cat, we will see how many times cat appears in this sentence. So here you can see the cat appears in this sentence is 2. Okay. Now we will count the total number of words. So total number of total words. So 1 second. You can change the color. So total words in the above sentence so you have to count 1, 2, 3. This way we can count 5, 6, 7, 8, 9. So our turn frequency is so total word count is 9. So 2 by 9, right? So this is our turn frequency. So this way you can calculate a turn frequency. So the formula we arise finally for Tf. So you can consider this Tf as a function, right? And in Tf we can pass two parameters. One is term tree and one is the document one, right? So based on that we can imply so number of occurrence of term t divided by total number of word in the document. So this is our term frequency. You can write it down on your notebook. So this is the formula of term frequency. So the total number of occurrence of term t in the word. Sorry, I have to also mention in where. So in the sentence or in the document you can say, and also the total number of word in that document. So at first the total number of term, specific term means this t, and then the total number of word in that document, right? So this is the specific term we are searching, that term. Okay, so this is our formula for turn frequency. Okay, now we will see how inverse document frequency works. So inverse document frequency means IDF. So IDF means inverse document frequency. So inverse document frequency means this basically reduce the weight of the common word and increase the weight of the rare word. So increase the weight of the rare word means the specific word which we are searching in that document. So it will increase the weight of that word so that we can find that particular term easily, and also at the same time it will reduce the occurrence or the weight of the common word. Okay, so what are the common word and what are the most important word, right? So like words like the, then, is, then, on appear in almost every document, right? So these words are also not useful for finding the correct word, so you can consider it as not useful. So in that perspective, these words like connecting word, conjunction, some articles, the, is, on, and these kind of words are not useful word. So IDF basically reduce the volume of this kind of word, right? Instead of that, the words like in the previous sentence we are finding for the term cat. So like the words like cat, I mean the specific term which we are finding, right? And also it will appear in fewer number of occurrence you will find in each document. So like if we have multiple document 1, document 2, document 3, first document is containing cat, second document is also containing the cat. So but the appearance wise it will only occur once or twice in a whole whole document. So it will find for that rare word. This is a useful word, you can say. So basically it will reduce the number of words which occurred multiple times, like the, is, on, and, conjunction, article. These things are not useful, right? At the same time, the cat, you see, this appears only once or twice, so it will increase the weight of that. So this way we can find the IDF of a particular, of a set of documents. Now we will see what is the formula for counting IDF. This is the concept, okay? Now we will see what is the idea of counting, what is the logic behind counting IDF. Let's see. So IDF of a word is basically equals to log total documents divided by documents containing the word. You see, like we are using one log sign over here. So what is the meaning of this log? So log basically we can take it as like maybe few of you don't know about logarithm or log. So for them I'm just explaining in few sentences. So log basically it's like for describing log we can say, like if we all know like 10 cube equals to 1000, right? So this complete expression we can expressed in a logarithm format. How? So we can do log 10 and we will put this value on the top. This becomes 3, right? So in log we have 3 component. One is like this is known as base, this is known as exponent, and this is the value. So for in a shorter version, like if we have multiple countings of like how many days, how many power of 10 is 1000, right? So the number is 3. So when we are calculating IDF, we also have that kind of scenario, because IDF is not only work for a single document, it will work for a huge number of documents. It's a summation of document. In IDF, it will find that particular word in a summation of document. Okay, so in that case, log will be very useful, because we can take the whole lot of document in one expression. So this way we are using log. So log means basically 10 to the power 3 equals to 1000, right? So like we can also take one more example. Instead of 10, we can take like 2 cube equals to 8, right? So you can do one thing, this value will come on the top and this becomes 3 but we have to use log, right? So in log, as I have said, this is known as base value. Base is always constant. Base can never be changed. Only exponent and the value will change, and 8 is the exponent and the value is 3. So this way we consider the log, and that's why we have used the log in the IDF as well, right? Now we will see how we can calculate the IDF. So now for calculating this, now if we have 3 documents and only one contains cat, then IDF of cat is like we have 3 documents, right? Doc 1, doc 2, doc 3. So we have 3 documents. Only one is containing cat, right? Then our IDF value would be IDF of cat equals to log 3 divided by 1. So here it is like 3 means the total number of documents. So this is n, you can say the total number of documents, and the term appears in all the documents. So maybe it occurs once in 3 documents, it occurs once. So this is the value. So log divided by log equals to 3 divided by 1. So this is IDF value. Now if I want to calculate the Tf-Idf together of any document, then we can do, we can just make it here, we are not clearing anything. So as you have seen, like if we have 3 documents, we are checking Tf. Okay, in first document we have seen like 2 times cat occurs, and the total number of word in that sentence is 9 times. So Tf is 2 by 9, and IDF we are considering maybe for that same. So we can say like we have 2 documents simultaneously, and so the total number of 2 documents and cat appears one single time, right? So 2 divided by 1, this is the log value. So Tf-Idf value should be Tf 9 into log, okay, let me clear this whole thing. Just take a note line by line so that we can make a connection between both. So the value Tf-Idf is, we have already seen Tf is 2 by 9 and the IDF is log, if the total number of document n means 2 and cat appears once, so this is my log. So this value is Tf-Idf, right? This is the most basic and the very simple explanation of Tf-Idf, right? So this thing we will calculate in Node.js. So don't be scared about this, because in Node.js we have separate module for implementing Tf-Idf. So that module name is natural. I guess natural means natural NLP value. So NLP means natural language processing. Natural language processing, this basically process human language. So from there this name came natural. So we have one npm in Node.js which is known as npm I natural. So they have all the built-in module. We just only need to pass these 2 parameters. Which 2 parameters? So for Tf we have 2 parameters, right? One is the term and the t. So we will pass in natural, we have certain functionality where we have to pass this term and the document, and based on that it will automatically calculate our Tf and Idf. So the project I'll be going to develop in this video, that is a simple resume matcher. It will match the resume based on the job description, and at the end of this video you will see the result will come as with the name of that particular person and the matching percentage. Maybe Ali's resume matched for 0.1, right? Maybe Bob, his resume matching percentage is 0.5. So this way it will come. Let's proceed with the Node.js video.